On October 22, 1975, a Soviet lander touched down on the surface of Venus. The lens cap, which had protected the camera during its fiery descent, popped off. The lander's camera began to scan its surroundings, line by agonizing line. This wasn't footage. In the modern sense, it was a slow, methodical panoramic scan, transmitted across hundreds of millions of kilometers of space back to a waiting Earth. Then, the image began to appear. It was the first photograph ever taken from the surface of another planet, and it was shocking. Not because of aliens or strange structures, but because of how utterly desolate and strangely familiar it was. The image revealed a stark, flat, and fractured landscape littered with sharp, angular rocks. There was no dust or sand, just a field of shattered stone under a dim, oppressive sky. Visibility was surprisingly clear, like an overcast day on Earth, but the light filtering through the thick clouds gave everything a strange, yellowish-orange tint. 3 days later, a second lander, Venera 10, touched down over 2,000 kilometers away and sent back another panorama. It showed a similar scene, but with smoother, weathered rocks. Venera 9 sent back its haunting images for 53 minutes. Venera 10 lasted for 65. Then, one by one, they succumbed to the crushing heat and pressure and fell silent. But their work was done. They had torn the veil from Venus forever. It was a barren, broken world, but the rocks looked like rocks. And it begged the question, what kind of impossible journey led to this moment? While the world was glued to images of American astronauts on the moon, the Soviet Union was secretly looking in the complete opposite direction. Their target wasn't the cold, silent vacuum of space or the dusty red plains of Mars. They were aiming for Venus, a planet so hostile it was nicknamed Earth's evil twin. For over 2 decades, the USSR waged a secret war against the most hellish environment in our solar system, sending a fleet of robotic soldiers into a literal furnace. For centuries, Venus was a planet of pure imagination. Wrapped in a thick, pearly white blanket of clouds, many believed that beneath its veil lay a lush, tropical world, a younger Earth, a humid jungle teeming with exotic life. In the mid-20th century, early American probes like Mariner 2 flew by and returned data that was deeply unsettling, hinting at surface temperatures hot enough to melt lead. For many in the West, Venus looked like a dead end. America largely turned its focus elsewhere. But for the Soviet Union, this wasn't a deterrent, it was a challenge. Driven by a relentless ambition to claim cosmic firsts, they embarked on one of the most audacious campaigns in space exploration. They wouldn't just fly by Venus, they were going to conquer it. They were going to land on its surface, and they had absolutely no idea what they were getting into. The Soviet effort to reach Venus began in 1961 with the Venera program, a name that simply means Venus in Russian. The early missions were a catastrophic string of failures. Venera 1, launched in February 1961, lost contact with Earth just 7 days into its journey. Venera 2, launched on November 12, 1965, suffered a similar fate, its systems overheating and failing before it could transmit any data from its flyby. Then came Venera 3, launched just 4 days after its twin on November 16, 1965. Its mission was simple: to crash land on the Venusian surface. On March 1, 1966, it achieved that goal, becoming the first man-made object to ever touch another planet. But it was a silent victory. Its communication systems had failed upon entering the atmosphere, and the probe sent nothing back. For the Soviet engineers, it was a terrifying puzzle. They were fighting an enemy they couldn't see. These early probes were being destroyed by something in the atmosphere, long before they had a chance to touch down. The dream of a lush, tropical Venus was rapidly being replaced by a stark and frightening reality. The planet was actively fighting back, and the Soviets had to design a machine that could survive a battle against an entire world. The consistent, baffling failures forced Soviet engineers to rethink their entire strategy. The problem wasn't the landing, it was the descent. They designed the next wave of missions, Venera 4, 5, and 6, not as landers, but as armored atmospheric probes. Their sole purpose was to survive the plunge for as long as possible and radio back the secrets of the environment. Launched on June 12, 1967, Venera 4 made its historic descent into the Venusian atmosphere. As it fell, its instruments began to paint a picture of a world more hostile than anyone had ever imagined. The probe confirmed the atmosphere was an oppressive blanket composed almost entirely of carbon dioxide. For 93 minutes, it transmitted data as it descended. Then, abruptly, at an altitude of about 25 kilometers, it went silent. The probe had been crushed. The final pressure reading was 25 times that of Earth's atmosphere. The American Mariner 5 probe, which flew by a day later, confirmed the grim truth: the pressure at the surface wasn't 25 atmospheres, but closer to 100. Venera 5 and 6, launched in 1969, were built stronger. Yet they too were crushed miles above the surface, surviving just long enough to confirm the horrifying data. The temperature was a searing 475 degrees Celsius, or 900 degrees Fahrenheit, and the pressure was an unimaginable 92 times that of Earth. The clouds weren't water vapor, they were laced with corrosive sulfuric acid. The dream of a sister planet was dead. In its place was the terrifying image of a planetary pressure cooker. Knowing the true nature of Venus, the challenge became monumental. For their next attempt, Venera 7, the Soviets built a machine that was less a spacecraft and more an armored bank vault. The descent module was a sphere of titanium, designed to withstand pressures and temperatures that seemed to defy physics. On December 15, 1970, it entered the Venusian atmosphere. The descent was harrowing. The parachute ripped during the final stages, causing the lander to plummet toward the surface far faster than planned. It hit the ground hard, at over 60 kilometers per hour, and toppled onto its side. For a moment, there was only static. But then, a signal emerged from the noise, faint but unmistakable. Venera 7 had survived. For 23 agonizing minutes, it sent back a weak but steady stream of data directly from the surface of another world, confirming the extreme temperature of 475 degrees Celsius. It was a monumental achievement. While the Soviets' Luna 9 had already achieved the first soft landing on the moon in 1966, this was the first time humanity had successfully landed a probe on another planet and transmitted data from its surface. They had touched hell, and for a few brief moments, it had spoken back. The success of Venera 7 opened the door for true scientific exploration. The next mission, Venera 8, launched on March 27, 1972, was equipped with more advanced instruments, including a gamma-ray spectrometer to analyze the composition of the rocks below. This time, the landing was smoother, and the probe survived for over 50 minutes. As the data came in, it revealed something astonishing. The spectrometer detected levels of potassium, uranium, and thorium in the surface rock. On Earth, these elements are commonly found in continental crust, specifically in granite. This was an electrifying discovery. Granite is a rock formed from the slow cooling of magma, a process often associated with the presence of water and plate tectonics. The finding was a profound paradox. Here, on the surface of this dried-out, superheated world, were rocks that looked a lot like those found on Earth's continents. It raised a tantalizing question. Could it be possible that Venus, in its ancient history, was a very different place? A world with oceans and continents? The soil of Venus was beginning to tell a story of a paradise lost. The Soviet engineers had to overcome impossible odds with every single mission. It makes you wonder, what do you think was the single greatest challenge they faced? The heat, the pressure, or the corrosive atmosphere? Let me know your thoughts in the comments below. And if you're finding this forgotten chapter of space history as fascinating as I do, make sure you hit that subscribe button and ring the bell so you don't miss what comes next. Those first black and white images were a triumph, but Soviet ambition only grew. They wanted to see Venus in color. They wanted to touch it, drill into it, and understand its chemistry. This led to the pinnacle of the Venera program. Venera 13 and 14, launched in 1981. These were the most sophisticated landers ever built, equipped with color cameras, microphones, and a robotic drill arm. On March 1, 1982, Venera 13 landed and returned the first ever color images from the surface of Venus. The landscape was bathed in an eerie orange-brown light, a world of flat, broken bedrock and dark, fine-grained soil. The probe then deployed its drill, boring into the Venusian regolith. The results were another revelation. The rock was a form of basalt, a volcanic rock extremely common on Earth. This finding screamed of widespread, active volcanism. Venera 13 survived for an astonishing 127 minutes, more than 2 hours in an environment that should have destroyed it in minutes. It even recorded the first sounds from the surface, the clank of the lander's own mechanisms and the thud of the drill. 4 days later, Venera 14 landed nearby and repeated the success. though a funny mishap occurred when its lens cap landed exactly where the soil probe was meant to test the ground. The remarkable successes of the imaging landers were followed by a final, ambitious phase. In 1983, Venera 15 and 16 were launched. These were not landers, but orbiters equipped with powerful radar. Skimming over the planet's north pole, they peered through the impenetrable cloud deck and mapped roughly a quarter of the Venusian surface, revealing massive shield volcanoes and strange, spider-like formations called arachnoids, features whose origins are still debated today. The final Soviet mission to Venus was perhaps the most elegant. In 1985, the Vega 1 and 2 probes flew past the planet. They each deployed a lander, but they also released something truly unique: 2 large, instrumented balloons. For about 2 days, these balloons floated through the middle layer of the Venusian atmosphere, about 50 kilometers up, where the temperature and pressure are surprisingly Earth-like. They drifted for thousands of kilometers, sampling the chemistry of the clouds directly and exploring the only region of Venus that could, in theory, be considered potentially habitable. And then, after the Vega probes, it all stopped. Why did they stop? By the mid-1980s, the Soviet Union was facing severe economic problems. The enormous cost of its own space shuttle program drained resources, and the political will to fund these incredibly difficult Venus missions evaporated. The collapse of the Soviet Union in 1991 was the final nail in the coffin. For almost 4 decades, no spacecraft has landed on Venus. The shocking footage sent back by the Venera probes was not of aliens, but of a planet that died. The grainy, panoramic images and streams of data told the story of a world remarkably similar to our own that took a catastrophic wrong turn. The Venera program proved the existence of the runaway greenhouse effect, a discovery that has become a chillingly relevant warning for our own planet's climate. The Venera program remains one of the greatest and most overlooked achievements of the space age. It was a testament to raw determination and brilliant engineering. The Soviets set out to conquer Venus, and in a way, they succeeded. They landed on it, saw it, heard it, and touched it. And the truth they sent back, written in the language of fire and pressure, is more terrifying than any work of fiction. The most hostile planet in our solar system may not be an alien world, but a dark reflection of Earth's own possible future.